Hi children. In last class we have discussed about bases. So we have defined bases and we discussed various properties of bases, and we have also discussed what all the bases are having in common. That is what OH minus ion. So in this lecture we are going to continue with the bases and also discuss about the ionization of acids and bases in water. So what are the uses of bases? So there are some important bases that we use in our daily life. So some of them are sodium hydroxide. So its chemical formula is NaOH. Sodium hydroxide, NaOH, is used in the manufacturing of soap, in the manufacturing of paper and artificial textile, rayon, artificial silk, it's rayon. So sodium hydroxide is very important chemical. It is used in the commercial purposes like manufacturing of soap, paper and textile industries. So next, calcium hydroxide. The chemical formula of calcium hydroxide is CaOH twice. So why there are two hydroxy groups are present here? Because here the metal atom is calcium and its valency is +2. Valence is nothing but its combining capacity. That means it can form two bonds. So since it is having a +2 charge, a dye-positive charge, it can be bonded with two hydroxide groups, so that the formula is CaOH twice. So calcium hydroxide, it is also called slaked lime. It is also called slaked lime. So this is used in the manufacturing of very important chemical called bleaching powder. Bleaching powder is having so many domestic and industrial applications. So earlier bleaching powder was used in the purification of drinking water. The process is called chlorination, but now and then the process is replaced with other purification techniques. So bleaching powder is manufactured from calcium hydroxide as a starting material. Next base is magnesium hydroxide. Similarly, the charge on magnesium is Mg+2. So since it is a dye-positive cation, it can attach to two hydroxides. So magnesium hydroxide is used as an antacid to neutralize excess acid in stomach and cure indigestion. So it is a very important antacid. So this question is also asked in so many examinations. Which of the following which of the following material is used as an antacid? So magnesium hydroxide. So magnesium hydroxide is a weak base, as we discussed earlier. So it's a weak base. So this is used to neutralize the excess hydrochloric acid that is produced in our stomach. Some people are having reflux in the stomach after heavy meals, and in such case an antacid tablet is suggested. That antacid tablet generally consisting of magnesium hydroxide. So this is also used to cure indigestion. Next one is sodium carbonate. Sodium carbonate formula is Na2CO3 and it is used as washing soda, and also it is used for the softening of hard water. So generally water can be classified into two types: hard water and soft water. The water which doesn't produce much lather with soap is called, or much foam with soap is called hard water. The water which produces much lather or foam with soap is called soft water. Usually our tap water is hard water, borewell water is hard water, and hard water can be softened by using sodium carbonate. Okay, And sodium hydrogen carbonate, next base is sodium hydrogen carbonate. It is used as baking soda. Its formula is NaHCO3. So what is this? Sodium hydrogen carbonate, or sometimes it is called sodium bicarbonate. Sometimes it is also called sodium bicarbonate. The other name of sodium hydrogen carbonate is sodium bicarbonate. So sodium bicarbonate is also a weak base. Generally, it is used as a baking soda and in our kitchens. And also, it can be used as an antacid and as a fire extinguisher. Usually, there is a powder. There are some powders which are used to put off fires. So in that powder, the sodium bicarbonate is the chief constituent in that. So we have discussed here. We have discussed about five important bases. So first one is sodium hydroxide, other one is calcium hydroxide and magnesium hydroxide, sodium carbonate, sodium bicarbonate. Sodium hydroxide is NaOH used in the soap, paper, rayon industries, and calcium hydroxide is called slacker lime. It is used in the manufacturing of important chemical bleaching powder, and bleaching powder is having so many applications. Magnesium hydroxide is a weak acid, it weak base. Sorry, it is used to neutralize the excess acid produced in our stomach. Hence, it can be called as an antacid, and it is used to cure indigestion. And sodium carbonate Na2CO3 is used as washing soda and also for the softening of hot water. And sodium hydrogen carbonate or sodium bicarbonate NaHCO3 is used as baking soda, antacid, and as a fire extinguisher. These are the important uses of bases. Then coming to the next topic, ionization of acids or bases in water. So ionization of acids or bases in water. And this is also called, what happens when an acid or base is added to water. So this can be discussed by performing the following activity. Actually, this activity is mentioned in your textbook, activity 2.9. So in this, what we are doing, so take 1 gram solid sodium chloride in a clean and dry test tube and set up the apparatus as shown in figure. See, I have taken a clean and dry test tube, and in this clean and dry test tube, 1 gram solid sodium chloride, not aqueous sodium chloride. Solid sodium chloride is introduced. So that test tube should be clean and dry. So to this, concentrated H2SO4, few drops of concentrated H2SO4 is added by means of a dropper. See, this dropper, by means of this dropper, I am adding few drops of concentrated H2SO4, not aqueous, concentrated H2SO4. I am adding to this. And then the mouth of the test tube is closed with a stop rubber cork fitted with a delivery tube like this. Then what happens after some time, after few seconds, we'll find a pungent smell gas is coming out of the delivery tube. So this gas is colorless actually, and this gas is having some pungent smell. It is difficult to breathe, right? This gas is called hydrochloride gas, HCl gas. Then how HCl gas is produced? By the reaction between sodium chloride solid and concentrated H2SO4. These two chemicals react together to form hydrochloride gas. So you should not allowed to call it as hydrochloric acid until unless you dissolve it in water, right? So it is hydrochloric gas only, HCl gas. So the gas is produced with HCl. So the chemical equation can be represented as, the best representation of the chemical equation is, so this is the reaction between NaCl solid, NaCl solid I have taken, plus H2SO4, concentrated H2SO4 I have taken, concentrated H2SO4, right? So here Na plus Cl minus ions are present, and here H plus SO4 2 minus ions are present. So this Na ions are going to react with sulfate ions to form Na2SO4. Since the charge on the sulfate ion is 2 minus, we need 2 sodium plus ions to balance the charge. So that is the reason why 2 sodium cations are going to react with 1 sulfate anion to form sodium sulfate plus. Then there are 2 Cl minus ions and there are 2 H plus ions. These two react to form HCl, 2HCl gas. HCl gas is produced. Sodium sulfate is a salt. This formed HCl gas in this test tube comes out by means of this delivery tube, right? So now we are going to test whether this HCl gas is having acidic property or not, right? So the gas evolved is tested with moist or wet litmus paper. So this is the litmus paper. This is first suppose it's a wet litmus paper and it is exposed to the outcoming HCl gas. It turns blue litmus to red. If it is a blue litmus paper, then it turns blue litmus to red, right? So if any substance that turns blue litmus to red, that is called an acid. So that we could say HCl is an acid. However, the same gas is tested with a dry litmus paper. Earlier, I have used a wet or moist test litmus paper. Now, the moist litmus paper is replaced with dry litmus paper. So, in this case, what could be your finding? You know, there is no color change is observed with dry litmus paper, though the same HCl gas is used. What could be the reason for that? So, however, the gas cannot change the color of the dry litmus paper, right? So, what is the difference? The same gas which is changing the color of the litmus when moist litmus paper is used or wet litmus paper is used. The same, however, the same gas is unable to change the color of the litmus when dry litmus paper is used. Let us see what could be the answer. Let us see. The above experiment shows that. So, what is our inference here? The above experiment shows that HCl gas does not show acidic behavior in absence of water, right? So, it shows, in other words, it shows acidic behavior. It shows acidic behavior in the presence of water. So, in absence of water, HCl is simply gas. It is not an acid, but in presence of water, it is an acid. It is behaving like an acid. It is changing the color of the blue litmus to red. So, what happens? We will study this in detail. So, dry HCl gas does not contain H plus ions in it, but when it is dissolved in water, it forms solution, HCl solution, HCl aqueous, which then produces H plus and Cl minus anion. You know, simple HCl gas is not ionized into H plus and Cl minus, but as soon as If you put this HCl in water, it undergoes ionization to form H plus aqueous ion and Cl minus aqueous ion. So this process is called ionization. The process of splitting of a compound into ions is called ionization. So this can also be represented like this. HCl when put in water, HCl produces H plus ions. These H plus ions are combined with H2O to form H3O and Cl minus ions. H3O is called hydronium ion. So why H3O plus ion is formed? Because H plus ions cannot exist alone, but they exist after combining with water molecules. After forming, hydrogen ions must always be shown as H3O plus after forming a hydronium ion, right? So this is the reason why dry HCl is not behaving like an acid. The answer is, in order to behave like an acid, it should produce H plus ions. A compound should produce H plus ions, or a substance should produce H plus ions. In case of dry HCl, there is no such provision for the production of H plus ions. But as soon as the HCl gas is mixed with water or moisture, as soon as it is mixed with the moisture, H plus ions are produced. Once H plus ions are produced, the substance can act as an acid. So it should be taken in mind, the experiment should be conducted in a dry atmosphere. Otherwise, if the experiment is conducted in a moist atmosphere, what happens? The dry HCl gas that is produced in the reaction catches the moisture in the atmosphere and it ionizes, and in such case it changes the color of the dry litmus paper, right? So the experiment should be conducted in absolutely dry conditions. So similarly, what happens when bases are dissolved in water? Same thing happens. Bases can also undergo ionization, but unlike acids, the bases produce OH minus aqueous ions. So these OH minus ions are responsible for the change in the color of the red litmus to blue. We know bases change the color of the red litmus to blue. We discussed it earlier. The reason for that is the OH minus ions that are produced in their aqueous solutions, they are going to react with their litmus and they are going to change the color of the litmus. So then for example, sodium hydroxide solid when dissolved in water, it is producing sodium plus aqueous solvated ion and OH minus aqueous. Similarly, magnesium hydroxide, since it is carrying two hydroxide ions, it is producing two hydroxide ions, right? So what have you learned in this ionization concept? All acids generate H plus ions and bases generate OH minus ions in water. And these H plus ions and OH minus ions are responsible for the change in the color of the litmus paper. Right? So dry HCl cannot be treated as an acid. So we are not supposed to call it as an acid. It is correct to call it as hydrogen chloride, not hydrochloric acid. Hence, neutralization reaction is, HX is an acid, right? Since acids should contain H plus, then I mentioned it as a HX, and MOH is it is a hydroxide and a metal ion, right? And M and X react together to form a salt, and H and OH, H plus and OH minus react together to form H2O liquid. So in other words, in simple, we can mention the neutralization like, H plus from acid and OH minus from base. So H plus aqueous plus OH minus aqueous gives rise to H2O liquid. This is also neutralization. So what have we learned in this? From this activity, what have we learned? So acids, what happens when acids and bases are put in water, what happens? They simply undergo ionization. Ionization is nothing but production of or splitting of a substance into ions is called ionization. Is called ionization. So whenever an acid or a base is kept in water, right, it undergoes ionization to form H plus and OH minus ions. Acids are forming H plus ions and bases are forming OH minus ions. So this ionization is responsible for the change in color of the litmus paper. If this ionization is not occur in case of dry HCl, it should not be act as an acid. So next, coming to other activity. This is also related to dissolution of acids and bases in water. So this is activity number 2.10 from our NCERT textbook. So what is the aim of this experiment? So dissolution of acids or bases in water is exothermic or endothermic. So we have to find out a simple experiment. So whether the dissolution of acid or base is associated with liberation of heat or not, right? So first we should know what is an exothermic process. So you might have learned about this in your lower classes. An exothermic process is a process in which heat is liberated, right? Exothermic process means heat liberated or released, or heat releasing process. And in contrast to endothermic process is a process in which heat absorbing process, in which heat absorbs, right? So our aim is to understand or to decide whether the dissolution process is an exothermic, in other words heat releasing, or endothermic, in other words heat absorbing process. For this, a simple experiment is conducted. So in this, what we do, take simply I have taken 100 ml of water in a beaker, right? I have taken a 100 ml of I have taken a beaker and it is filled with 100 ml water, 10 ml water, and to this a few drops of concentrated H2SO4 is added to it slowly and swirl the beaker slowly, right? So make sure, we have discussed, you are allowed to add acid to water, not the reverse addition. You are not supposed to add water to acid, right? So that's the reason why I have added few drops of concentrated H2SO4 to the beaker containing water, and slowly the contents are stirred. So touch the base of the beaker, then we will feel hot. If we touch the base of the beaker, we will feel hot. So what does it mean? Why we feel hot? Because heat released from the contents. So hence, since it is heat releasing process, this is called an exothermic process. Hence, dissolution of an acid in water is an exothermic process. So this is what the experiment we did. So I have taken a beaker containing water. To this, acid is added slowly, right, with constant stirring. This is the correct method, correct way of adding water, adding acid to the water, or dilution. This process is called dilution, and this is the wrong process. You are not supposed to do it like this. So if we repeat the experiment with sodium hydroxide pellets, the same experiment is repeated with base, then what could be our observation? Same. The dissolution of base is also associated with the liberation of heat, and this is also an exothermic process. Then the question is, why heat is liberating or heat is evolving when we are dissolving an acid or base in water? The reason is, the dissolution process, in the dissolution process, the ions are largely hydrated. That what we are mentioning, H plus aqueous cation, OH minus aqueous anion. This, because of this hydration, a large amount of energy is released. So this is called, sometimes it is called hydration energy, and this process is an exothermic process. The bonds, the energy that is present between the chemical bonds of these ions or atoms is releasing in the dissolution process. So these things, you learn about these things much detail in your plus 1 plus 2 studies, right? The lattice energy and hydration energy topics. So basically, what is our outcome here? Dissolution of an acid or base in water is an exothermic process, and there should be a cautious note: acid must always be added slowly to water with constant stirring. If water is added to concentrated acid, what happens? Heat generated, and it may cause the mixture to splash out and cause burns. Not only that, the glass container may also break due to excessive local heating. Right? So these are the two activities. So today we learned. So I am going to stop at this stage, and I am going to summarize the topics quickly. So today's class, we have gone through the important uses of some important bases. So one is sodium hydroxide. Its formula is NaOH. It is used in the soap and paper rayon industry. Sodium hydrogen carbonate, NaHCO3, also called sodium bicarbonate, and it is used as an antacid. It is used in used as a fire extinguisher, and also most important application is it is used as a baking soda. Sodium carbonate, formula is Na2CO3, used as washing soda, and it is used in the what you call that, softening of hard water. And calcium hydroxide, also called slaked lime, and its formula is CaOH twice. So it is used in the manufacturing of important chemical called bleaching powder, and bleaching powder, its formula is CaOCl2. Then magnesium hydroxide, which is a weak base, always used as antacids or to treat indigestion, right? And we have studied the ionization of acids and bases in water. Then we learned acids produce H plus ions, bases produce OH minus ions, and the important equation is preparation of hydrochloric acid from NaCl and H2SO4. This reaction is asked many times in our board examination also. So that is very important. So 2 NaCl plus H2SO4. Why 2 NaCl? We have explained sulfate H2SO4. In H2SO4, sulfate is having 2 minus charge here. So that is the reason why you need 2 Na plus ions. So NaCl reacts with H2SO4 to form sodium sulfate salt and HCl gas, dry gas. So then we have also learned what is an exothermic process, endothermic process, and dissolution of acid or base is always always exothermic process. And always remember, add acid to water, not add water to acid, to prevent accidents. That's it for today's session. Dear children, I strongly recommend you to go through the previous video also, as we are having a slip test soon. So you have to answer the questions. You have to answer all the questions. It is not possible to answer those questions without going through the video or the lecture notes again and again. That is the reason why I am strongly recommend you to go through the lecture notes once, and to go through the video lecture once. And also, I know most of the people are not watching the video completely, and some of are not at all watching. So I can track everyone who is watching my video by using YouTube Studio software. So I know the persons who are watching the video and who are not watching the video. So keep that in mind. So please go through the video entire lecture, and if you have any doubts, uh, post in the not in the group, to my personal WhatsApp number. Thank you so much.